Welcome back to the class, guys. So in this entire module, you are going to learn about networking devices and few other concepts like network devices, IP addresses, MAC addresses, TCP three-way handshake, and so on. If you are well aware of these concepts, or if you have learned any courses like CCNA or Microsoft related courses, you may skip this module. And if you are a beginner, then you should continue with this module and learn these concepts. So in this particular class, we are going to learn about networking devices like hubs, switches, routers, firewall, IDS and IPS devices like intrusion detection systems and intrusion prevention systems. This class is important for you because you have to encounter networking devices while you are conducting penetration testing for remote sites, or in corporate environment when you are conducting penetration testing, you are not only going to exploit the vulnerabilities that are there in the computer systems or the applications, but you should also find the vulnerability in networking devices like routers. So you have to find the weakness in a router, that is vulnerability, and try to exploit them. So in order to do that, you must first understand these devices and their functionality. For example, routers and layer 2 switches have IOS, that is Internet Networking Operating Systems, which are configured by the network administrators and managed and monitored by network security administrators as per the company's requirement. So let's begin the class. Let's start with the hub. So what is a hub? Hub is a network device and it has ports, multiple ports like 4 ports, 8 ports or 16 ports, and used to connect Ethernet based devices. Ethernet based devices are like your computers which has Ethernet port. And when I talk about ports, there are two types of ports. One is a physical port to which devices are connected, while the other is a logical port, and logical ports are channels that are used for data communications of any particular service, like your browser works on port number 80. So now regarding the Ethernet ports, as you can see over here, it has a cable, mostly a Cat5 cable or Cat6 cable, and has a connector that you are seeing over here, and it is called as a RJ45 connector. And most of your systems, computers or laptops, even switches and routers have these kinds of Ethernet ports and can be used for connecting the devices. Now hub. Hub, as said, is a multi-port device, and you can connect multiple devices to the hub for creating a network, and the entire network is considered as a single network segment. Hub works at layer 1 of OSI model, that is physical layer. And if you don't know what is OSI model, don't bother. We are going to learn about OSI model in this same module. And as said, hub works at physical layer and is unintelligent device. It means that whenever hub receives data, it sends the data to all the devices that are connected to this hub. For example, in this image, you are seeing totally 5 ports other than the uplink over here. So if 5 devices are connected to this port, the hub sends the data to all the 5 devices that are connected to this particular hub, and hub creates a star network topology. If you have knowledge on network topologies, that is structure of a network, there are different kinds of network topologies like bus, star, ring topology, mesh, tree, and point to point. So hub forms a star network topology. As you can see in this image over here, 4 computers are connected to this hub and forms a star topology. Hubs also acts as a repeaters. So what are repeaters? Repeaters are again network devices that amplifies or regenerate the incoming signal before transmitting them. So hubs are also repeaters. Hubs are now almost obsolete. You will hardly find hubs in corporate environments. When I was a child, a school student, I used to see hubs in my school computer laboratory where computers are connected to these hubs. And hubs are replaced by switches. So as said, hubs sends data to all the ports or all the devices that are connected to hub. So it considered as a broadcast messages. So hub sends data as a broadcast messages. And the transmission mode in the hub network is half duplex. Half duplex simply means when I am talking, you should listen, or when you are talking, I should listen. Just like your walkie-talkie, means when one device is sending data, the other cannot send. Data transmission takes once at a time. It means only in one direction at one time. By the way, the term duplex means a capability to send and receive data. So transmission mode in hub network is half duplex. And data collisions occurs in these kinds of networks. Data collision means when two devices are sending data at same time, they collide, and this leads to chaos in these kinds of network setups. And this kind of scenario is considered as a collision domain. So just remember, hub sends data to all the devices that are connected to the ports of a hub, and hubs do not segment a network. And since hub network is considered as a single network segment, hubs are also used to connect network segments. And as said, hubs are nowadays obsolete and are replaced by switches. So let us learn about a switch. So what is a switch? As you can see in this image over here, we have two switches. One is Netgear, as you can see over here, and it is 24 port switch, and we have 24 port switch as well over here also. So these both devices are switches. So what is a switch or a network switch? Again, switch or a network switch is a networking device that is used to connect devices like your computers and other Ethernet port devices like hubs, switches and routers as well. And switches are used to create networks, and they use packet switching method to exchange data between the network devices that are connected to these switches. Packet switching is nothing but grouping of a data into a packet to transmit over the networks. So packet or a data packet is nothing but a datagram or a small block or a unit of a data, or you can say a frame of a data, and data packets together form a message. So switches use packet switching method to transmit or exchange data between the devices in a network. And like hub works at layer 1 in OSI model, switches works in a layer 2, that is data link layer of OSI model. Again repeating, don't worry about OSI model. We will discuss about OSI model in the same module in different class. And as said, hub is unintelligent device, but switch is an intelligent device. It means that it does not send data to all the ports, means all the devices that are connected to the switch. Instead, it will send data to only that particular device to which the message or data is intended to receive. For example, if you are seeing in this image over here, we have a couple of computers connected to this switch. For example, the machine or the computer which is connected to port number 16 should receive this message. Then the switch learns its MAC address and sends message to this particular computer only. And hence switch is considered as an intelligent device. And MAC address is a physical address of device. And you are going to learn about MAC addresses in the same module. But how does a switch sends data to that particular device only? Whenever a device is connected to a switch saves the physical address of that device in its MAC table or switch table. And whenever a machine, say for example in this image, a PC1 wants to send a message or a data to PC number 16 or machine number 16, then the switch will look its switch table or MAC address table and will send data to that port, as you can see in this image. So let me change the example. Let me assume that machine 1 wants to send some message to machine number 7 or PC number 7. Then the switch will look at its table, that is switch table, and 19FFFC91-2A19, that is MAC address of a machine which is connected to port 7, and the data is sent to that particular port only. And this is why switches are considered as intelligent devices than hubs. As said earlier in the class, transmission mode in hubs are half duplex, that is only one device can send data at a time. The transmission mode of switches is a full duplex. It means that Ethernet port can send and receive data at the same time. And switches also works or functions as a network bridge. Means two different networks can be connected using a switch. And of course uses MAC addresses to forward the data. And switch is a multicasting device or a multicast device, unlike hub which is a broadcasting device. We know networking devices are used for communications, and there are three types of communications primarily. That is unicast, broadcast and multicast. Unicast means one-to-one communications, like I am talking to my girlfriend only. While multicasting can be described as a communication between one to many systems, one machine to many systems, like I am talking to bunch of useless friends in a room. While the broadcasting or broadcast can be defined as the communication from one machine to all the machines. In multicasting, there are all the systems, but you are actually talking to only few systems. But while in a broadcast, you are sending message or data to all the systems in a network, like a politician giving speech in a public area, or like your BBC News, British Broadcasting Corporation, where the news is broadcasted and everyone can listen or watch the news if you are subscribed to that channel. And when it comes to the network, if a computer is connected to a particular network and the network has a broadcast message, then all the devices that are there in the network will receive that broadcasted message. And switches works in a broadcast domain. We have discussed earlier, hubs works in a collision domain and switches works in a broadcast domain. So again remember, switch is a multicasting device, and Kalpana is the first multiport Ethernet switch which was developed by Mr. Vinod Bharadwaj and Larry Blair, and the device or the company was named after his wife Kalpana, and later the company was acquired by Cisco Systems. So most of the networking devices like your routers, switches are manufactured by Cisco Systems along with few other very good companies like Netgear, Juniper and so on. And as discussed, hubs works at layer 1, that is physical layer of OSI model. Switches will work at layer 2, that is data link layer in OSI model. And next we have routers. Routers works at layer 3 in OSI model. So what is a router? As you can see in this slide, in this image over here, we have two routers. The top one is from Juniper and the bottom one is made from Cisco Systems. This router is Cisco 1800 series model, mostly used by small and mid-level companies. And if you observe carefully, these devices also have ports similar to that of hub and switches, and these are Ethernet ports. Now before going to learn about what a router is, let me give you a small description on these ports. There are three kinds of Ethernet ports: Ethernet, Fast Ethernet and Gigabit Ethernet. Ethernet is a network communication protocol that is actually designed to link network appliances like your switches and routers. And when these appliances or devices are connected to these Ethernet ports, then how fast these devices can access the data, that is data transfer rate of the device that are connected to these ports, are differentiated on the types of ports like we discussed: Ethernet, Fast Ethernet and Giga Ethernet. Ethernet port can send or receive data, that is data transfer rate of Ethernet is 10 Mbps, megabits per second, while Fast Ethernet has data transfer rate of 100 Mbps and Gigabit Ethernet offers or has a data transfer rate of 1 Gbps, that is 1 gigabits per second. And back to the routers. As you can see on the screen, the Cisco router has 8 ports, which could be Ethernet ports or Fast Ethernet ports. But this particular model, which is Cisco 1800 series, might not have supported Gigabit Ethernet, I don't know. But currently we have Cisco routers or other routers which are supporting Gigabit Ethernet ports like Cisco 900 series integrated service routers, ISR routers, which are particularly for enterprise small networks, enterprise routing for small networks or home offices, which has 4 ports and also supports GE, that is Gigabit Ethernet. So let us come back to the slide. What is a router? A router is again a networking device that works at layer 3 of OSI model, that is network layer, and used to route the data between the different networks. The function of the router or routers are responsible for receiving a data packet, analyzing and forwarding the data packets among different computer networks. When the data packet arrives to the router basically inspects the packet for the destination address by consulting or checking its routing table. In the switch we have MAC table. Switch looks at the MAC table and sends data to a port which matches to the MAC address. But the router looks at a routing table and decides where to route the packet, means to which interface on the router should the data to be forwarded, because that interface is connected to some other network. And when I say interface on router, it is again a port, and different networks are connected to different ports or exit interfaces. So basically router stands like a traffic constable in a network traffic and routes or directs that network traffic to different direction, that is different interface on the router, and that interface is connected to some network. And the routing of the data is based on different routing protocols. Understanding routing protocols is out of scope in this course, but in the lab module, I am going to show you how to configure a router so that you can understand how router functions, and at that time, I will give a small brief on routing protocols. Now the examples of routing protocols as you can see on the slide are RIP, BGP and ISIS, that is Routing Information Protocol, Border Gateway Protocol and intermediate systems to intermediate systems. And router functions both in LAN network and WAN network, that is local area network and wide area network. As you can see in the slide, this router is connected to two switches and have two computers connected to each of the switches. So this is a small typical example for a LAN environment, and this right side you have a blue router that is connected to two routers, the red color, which are in the red color, and these red color routers are connected to a switches, and this is a small typical example of a WAN network. And routers have LAN ports and WAN ports separately, and mostly as said routers are manufactured by companies like Cisco, D-Link, HP, 3Com, Juniper, Nortel and etc. And routers have routing tables, and these routing tables typically contains IP addresses and subnet masks of the nodes in the network and IP addresses of the routers in the network. There are two types of the tables basically, a static routing table and a dynamic routing table. In a static routing tables, routes are fed manually and are not refreshed automatically. While in dynamic routing table, destination routes are determined by the routing protocols, and basically it keeps refreshing the routing table periodically. And there are different types of routers like wireless router, broadband routers, core routers, edge routers and routers. Wi-Fi routers are typically used in homes for Wi-Fi connections so that you can connect your laptops, smartphones wirelessly, and supports a range up to 150 to 300 feet. And broadband routers are used to connect to the internet through telephone to use VoIP, that is Voice over Internet Protocol technology, for providing high-speed internet access. They are configured and provided by your ISPs, that is Internet Service Providers. Core routers route the data packets in a given network. They actually cannot route the packets between the networks. They are used to link the devices within a network. And routers are different kinds of routers that has a functionality of a bridge, means connecting two different networks, standing as a bridge between two different networks. And in this course we are going to pen test the routers. So we are going to learn more about the router configuration in the lab section and as well as in the penetration testing part of this course. So next we have firewall. As you can see in this image over here, we have two firewalls. One is Cisco ASA 500 and the other is Cisco ISA 3000. ASA stands for Adaptive Security Appliance and ISA stands for Industrial Security Appliance. But what the heck is firewall? As you can see in the slide, router is used to route the data packets. Router simply forwards or routes the data packets to different direction or to different interface, while the function of the firewall is to inspect the data packets before forwarding them. So firewall is a network security device. It's not only just network device, but it is a network security device that monitors, inspects or analyzes the data that is coming and going through the firewall and decides whether the data packet should be allowed to forward or to deny the data packets based on the security policies or security rules that are configured on the firewall. ACL is an access control list. It is a table that contains these security rules that actually determines how a traffic or a data packets are forwarded or blocked. If there is a malicious traffic or a suspicious traffic, then the firewall will block the traffic from forwarding it. And there are basically three types of firewalls: packet filtering, application or proxy server, and hybrid firewalls. Before learning about types of firewalls, we have already discussed what is a data packet. Say for example, you are downloading some data from the internet, like you are downloading a file or you are downloading a movie. So entire file, which is say for example is 1 GB. So you will not receive data of 1 GB at once. The data is downloaded in the form of small packets, say for example 2 MB or 5 MB or 10 MB each. So these data packets have information of senders and receivers IP address, and the other portion is part of actual data, not complete data but the part of actual data, because it is a data packet of the whole message or whole file in this case. And this part of a data is called as a payload. So packet filter firewalls only checks the information, that is senders and receivers IP address and port numbers. It does not checks the payload, means the part of actual data, and if access control list have the rule of allowing this data, means allowing IP addresses that is to and from mentioned in the data packet, then the data packets are forwarded through the firewall. And since packet filtering firewalls does not check the payload, that is the part of data, hackers or cyber criminals can send a malicious payload along with the actual payload and can bypass the firewall very easily. So packet filter firewalls provide very low security since it does not inspect the payload portion of a data packet. Next we have application or proxy firewalls. When I was studying engineering, we have 60 to 70 students in a class, and when I used to bunk the class, my friend used to give the attendance on behalf of me. When the teacher or the professor shouts my name, my friend says, "Yes sir." So I used to get the attendance on that day. It means that my friend is a proxy of me, means he is acting on behalf of me. So whenever you are using a proxy, say for example you are accessing some website using a proxy firewall, then the website logs the IP address of the proxy firewall, but not the actual person, that is you, who is actually accessing the data. So proxy firewalls or application firewalls are also considered as a gateway firewalls because it blocks your internal traffic, say for example company's internal traffic, from being exposed to internet. And out there on internet there are so many cyber criminals, and from them these firewalls can protect you or your company. Unlike packet filtering firewall, which only checks the senders and receivers IP address and port number, proxy firewalls checks the payload as well. It means it analyzes the data packet completely, including the information as well as the payload portion of the data packet. Now, hybrid firewalls. Hybrid firewalls are the combination of both packet filtering firewalls and proxy firewalls and are connected in series to enhance the security for the company. Next we have IDS and IPS. IDS stands for Intrusion Detection Systems and IPS stands for Intrusion Prevention Systems. So before talking about IDS and IPS, you know who an intruder is. In the first module, you have already learned who the intruder is. Intruder is a person who intrudes or infiltrates, means deliberately getting unauthorized access to the target. That could be a network or a systems. And with respect to a corporate environment or your home systems, an outside intruder is called as a masquerader. He has no access to our computers or to our network resources. However, an inside intruder, who is also called as misfacer, has access to the resources on the network because he is an insider person. Even though inside intruder or misfacer has access to certain resources, means he is authorized to access certain resources over network, but he also may not have authorization or may not have permissions to access some other resources which are there on the same network. Say for example, a company have two different departments or so many different departments. A disgruntled employee who is a misfacer and is working in IT section of a company may not access the files that are related to a finance section or a finance department. So as an inside intruder, he is more dangerous than a masquerader who is an outside intruder. And if this guy who is misfacer has hacking skills, who can exploit the vulnerabilities of inside systems or a network, then he can easily get access to unauthorized resources over that network or in that company. And blocking cyber attacks from outside intruder, that is masquerader, is easily when compared to that of a misfacer who is attacking from inside network. So intrusion detection system is a hardware device, a monitoring system which has a monitoring software installed on it. And the function of this IDS is to detect the malicious traffic, unwanted or suspicious traffic that is coming from the outside network as well as the inside network. And it only generates the alerts and sends to the network administrator or network security administrator. Intrusion detection systems does not blocks the traffic. It allows the traffic, however, it generates an alert based on the rules that are written in the monitoring software application. There are two types of IDS systems. Host-based IDS, that is HIDS, and network-based IDS, that is NIDS. Host-based IDS systems, host intrusion detection systems, runs on independent devices on a network. Basically, it monitors the incoming and outgoing packets of that particular system, and if any suspicious traffic is found, then an alert is generated and sent to the administrator. While network intrusion detection systems or network-based IDS are devices that can monitor the entire network traffic. That is, it can monitor the traffic that are coming from the all devices in that network and will generate alerts when a suspicious or malicious traffic is found. And as said, IDSs are devices which has monitoring softwares installed on them, and these softwares has detection methods to detect the malicious traffic. And there are two types of detection methods: signature based detection and anomaly based detection. So what is a signature based detection? In real life, you might have seen or read somewhere about some criminals whose style of doing crime, whether it is stealing or doing a murder, has a pattern of doing crime, and it is called as modus operandi. And if you have seen some films, thriller films, you see a criminal kills so many people in a same way or a same fashion, and police personnels have a record of these patterns because they might have seen such kind of crimes in earlier cases. So based on that pattern of crime, officers will carry their investigation to find the criminal. Similarly, in corporate network or corporate environments, these IDS monitoring softwares have patterns or signatures stored in its database. Say for example, there is a malware attack on a company and a DOS attack on a company. So both attack patterns are different. Malware attack pattern is saved in the IDS. Then IDS detects the attack based on the pattern that is saved in the database and generates an alert and sends to the administrator for an action. These types of detection method, that is signature or pattern based detection, are also called as knowledge based detection because you have already knowledge on such type of attacks. And when it comes to anomaly based detection, network traffic is analyzed by the IDS software for an abnormal behavior in the traffic. For example, you have a server, web server or any server in which you need to authenticate using your username and password. And if the IDS detects repeatedly failed login attempts, this would be understood as abnormal activity. And when such activity is found on a network, an alert is generated and sent to the administrator. Companies establish a trustful activity model in IDS. So trustful activity means known traffic movement and is saved in the database. So when unknown or abnormal traffic activity or network activity is found, it is compared with the trusted activity and checks for the abnormalities in the traffic, and if found suspicious, then the alert will be generated and sent to the administrator. So these are the two detection methods of IDS systems. Next we have an IPS, that is intrusion prevention systems. I have one line statement to define the IPS, that is intrusion prevention systems, which is also called as intrusion detection and prevention system. The functionality of IPS is IDS plus blocking mechanism. It means detection and prevention. If a malicious traffic is found on a network, IDS only generates alerts. However, IPS will also block such traffic, such malicious traffic, and sends alerts to the administrator. And there are different types of IPS systems, that is network intrusion prevention systems, wireless intrusion prevention systems, network behavior analysis, and host based intrusion prevention systems. Network based intrusion prevention systems monitors the entire network for suspicious activity by analyzing protocol activity and then blocks if any suspicious activity is found. Similarly, wireless intrusion prevention systems monitors wireless network traffic for suspicious activity and then blocks the suspicious or malicious traffic and then sends alerts to the administrator. Network behavior analysis (NBA) examines the network traffic to identify threats that generate unusual traffic flows such as DOS attacks or distributed denial of service attacks and specific forms of malware and policy violations. And finally, host-based intrusion prevention systems or software packages which operates for a single device or a single host for any suspicious activity, and when such event occurs, it will take necessary action based on the configuration. And next we have load balancers. When we are conducting penetration testing or remote penetration testing, we have to find the load balancers. Because, say for example, you are conducting a pen testing on an application server, and when you are conducting penetration testing, like by sending malicious traffic to a application server or sending intentionally crafted data packets to exploit some vulnerability, you may be routed to different application server instead of your target by the load balancers. So, what are load balancers? As you can see, this is a web server or some server that is running some service, and if I am going to access some resources on these servers like files or downloading files, I will not encounter any kind of problem because I am the only person who is actually accessing resources on this server. But what if this is a scenario? Here so many people are accessing resources on this web server. Say for example, so many people are trying to open a facebook.com or a google.com page. At the time, this server cannot handle the load of all the traffic that is generated or requested by these users. In such scenarios, Facebook company or a Google company or any other company cannot close their operations or business when such a load is required to handle, and they have to find out the solution in order to handle such a load. And companies will create identical application servers that are performing or that are serving same service to all the users who are requesting that service. So as you can see in the image, there are 5 web servers which are handling the load that is generated by all these users, and the load is distributed among all these 5 servers. And how the load should be distributed among these 5 servers is the job of a load balancer. And here is the place where network load balancers or load balancers participate in network performing load balancing among all the 5 servers. So load balancer is basically a network device that acts as a reverse proxy and distributes the traffic generated by so many users among all these 5 servers. So for example, in this scenario we have load balancer, and when the application server on the top, that is number 1, is working at full capacity and unable to handle the load, then the load balancer will share the load with the next application server and so on. Cybercriminal attacks servers or corporate networks with a kind of attack or type of attack called as a DOS attack, which is denial of service attack, where hacker or a cyber criminal sends large amount of data to the target he want to exploit, and when such a large amount of data is sent, a network bandwidth is consumed and a congestion will take place, and the target will not be able to serve its service to the legitimate users. In such scenarios, load balancers are very helpful to eliminate single points of failure. It helps in reducing the attack surface of DOS attacks and makes it very hard to exhaust the resources and saturate the links. So make sure whenever you are conducting a remote penetration testing, you have to find out the load balancer also. So that's it in the class, guys. Have a great day. Thank you for watching the video, and do subscribe to the YouTube channel INSECTECHS.